we're going to see the different ways to interpret some risk. We're going to see the odds ratio, relative risk, absolute risk, attributable risk percentage, absolute risk reduction, relative risk reduction, and maybe number needed to treat and number needed to harm. I think that is everything. Alright, so let's begin. We have a 2 by 2 table. Here we have the, let's say, the disease that we are measuring, disease and non-disease, let's say disease and non-disease. And here exposure factor, risk factor, and non-exposure risk factor. Exposure factor, or the factor that we're considering to be a risk factor. We will have here A number, B, C, D. Remember, odds ratio is for case control studies, relative and attributable risk are for cohort studies. Alright, so in odds ratio, we are measuring the odds the same way we measure odds in probability, like what's the odds to pick a 6 in the rolling of the dice to odds of non-6. This would be the probability of obtaining a 6 in rolling dice is 1/6, and in obtaining a no 6 is 5/6. The odds ratio is 1 to 5. Here the odds is the same. First we need to calculate the separable probability. So first the odds ratio is you could see it in two ways. One way is probability of disease in the exposed divided by the probability of disease in the non-exposed. So this would be probability of having disease in the exposed group is A divided by B. Actually, I don't know if this table is usually done like that, because it's not worth to memorize if this cell is A, B, C, D, whatever. I just invent here the numbers, and I'm going to do it as I know if disease, non-disease, a risk factor or non-risk factor, or exposure factor and non-exposure factor, whatever. Just be careful, because I don't know if this is the way in which you are going to see the table. So, well, let's continue. So, this is the probability of having the disease in the exposed population divided by the probability of having the disease in the non-exposed, that is C divided by D. So, C divided by D. So, this is A, D divided by B, C. You could see it this way, or you could see it as instead of the odds of disease in the exposed group to the odds of the disease in the non-exposed group, see it as the odds of look, here you are having probability of disease in exposed group, and here probability of disease in non-exposed group. So let's see it first now with exposure and the non-exposure. So in the disease group, so now we're going to do the odds. Now, instead of odds of having disease in exposed versus odds of having disease in the non-exposed, now is odds of being exposed in the disease group and odds of being exposed in the non-disease group. So here would be in the disease group exposed and divided by non-exposed is A divided by C, and odds of being exposed in the non-disease group is D divided by B. Here I put probability, but maybe actually you could not see it as probability, because probability would be here, instead of being A divided by B, would be A divided by A plus C. Well, you can think like that. I think that is pretty much clear. Alright, so A divided by C and then B divided by D. You have again A times D divided by B times C. So it's exactly the same. So it doesn't matter which ratio or which odds you want to see. Just is the disease and exposure times the non-disease and non-exposure divided by the other two. But remember that it's more of thinking more than of memorizing. This is the odds ratio and is used in case control studies. Also, the interpretation would be, let's say this odds was 8. So it's interpreted as there is 8 times more probable that a person with this disease have been exposed to this exposure factor. So this is in the back time. Now for relative risk and attributable risk, that is for cohort studies. So here's the same, just that remember that in cohort studies we begin with the exposure factors and we follow to see the outcomes of the disease. So relative risk is the risk of the disease in the exposure group divided by the risk of the disease in the non-exposed group. So here, risk of having the disease in the exposure group is A divided by A divided by A plus B. And the risk of having the disease in the non-exposed group is C divided by C plus D. So the relative risk is A times C plus D divided by C times A plus B. And remember, it is not worth to memorize this stuff. It's A times C plus D. I don't remember this. I just calculate this, or I just infer this. So usually I do it like that. The probability of having the disease in the exposed group, that is A divided by A plus B, and then I divide this in the probability of having the disease in the non-exposed group, that is C divided by C plus D. This is the relative risk, and if this is, let's say, 8, you read this as if a patient has this exposure factor, is 8 times more probable to develop the disease than this person that is not exposed to this exposure factor or risk factor. Remember that in the relative risk, you have, if it is less than 1, is a protective effect. If it is 1, there is no difference, and if it is more than 1, is a risk factor. The attributable risk is the risk of having the disease in the exposure group, that is A divided by A plus B, minus the risk of having the disease in the non-exposed group, that is C divided by C plus D. This is the attributable risk, and it's just how much outcomes of diseases can be attributable to the exposure factor.